Okay, so we're going to look at the first derivative test today. The first derivative test is going to tell us how to classify critical points. So once we found our critical points, then we're going to be able to tell if a critical point is a local extreme, and then more specifically if it's a local min or a local max. Okay, so my plan today is to go through and just go through what the first derivative test is going to tell you, and then in the next video I'll do some examples. Okay, so what the first derivative kind of tells us is if the derivative, now this is key, it has to be the first derivative. So you have to look at the values of the first derivative. If you look at those values, if you have a negative derivative and then it turns into a positive derivative, because we know critical points can be where it changes. So let's think about what happens for an example that's going to occur here. So if I take a function, okay, I'm going to do two different graphs, okay, and both are going to have a negative derivative and then a positive derivative, okay. So if I'm taking a negative derivative, that's going to be sloping this way. So a graph like this could be looking like that. Okay. The other way it could be looking is a negative derivative. I could have a graph that kind of comes down like this. This is a negative derivative. Okay. This has a negative slope, the derivative. And then I'm going to take a positive derivative here. So if that's the case, then this would be a positive derivative here. Now, same thing happens. I can go negative, and then I can go positive. Okay. Either way, it's pretty clear that this is a local min. Okay. Now, let's look at it from the reverse. Let's say we had a positive and then it became a negative. If that's the case, then I'm having a positive slope. Okay, so it's going to be something kind of this way. So positive slope's going to go here like that, and then I've got to have a negative derivative, so it's going to look like that. Okay, I could also come straight up, be positive like that, and I could come right back down and be negative. Okay, that's pretty clearly a local max. Okay, so let's say that there is no sign change, Okay, so for an example, you're going, maybe we'll look at an example where it goes positive to positive, and then I'll look at an example where it goes negative to negative. Okay, so let's say it went positive to positive. I could look at an example like this where I take, here's my coordinate plane, and if it went positive to positive, it'd be something that kind of came up, all right? So it's coming up, but then it just keeps going up. Here's my critical point right here. It goes positive to positive, and it keeps going up. This is not a local extrema, not a local extrema. Okay, now, if we say, let's say we looked at a different graph, and we're going to go negative to negative. So that's something where, okay, the graph comes down, it's looping. Okay, here's your critical point, and it starts going down, back down again, negative to negative. Again, not a local extrema. So first derivative test tells you if you have a sign change, negative to positive, it's a local min. Positive to negative, it's a local max. If there is no sign change, then there is no local extrema. In the next two videos, look for some examples.